Okay, this lesson is about trig functions of general angles. So what we're going to be doing is we're going to be finding the 6 different trig functions again, but we're going to take it a step further. We're going to talk about things that are called reference angles, and then we're going to kind of finish it up by doing something. And some of you are going to have a little trouble with this, but it's very doable. It's called finding the exact value of a trigonometric function. When we are given, like the sine, for example, a 120-degree angle, can we find its exact measurement by using the tools that we're going to learn here? Okay, so the first thing is we're going to look at trig functions and general angles. All right, what this means is we're trying to find the 6 trig functions given a point on the terminal side of an angle. So the terminal side, remember, is the side of the angle where the angle where theta kind of finishes. And we're going to be given a point over on that side. Okay. So how we do it, the first thing we're going to do is sketch the point on the coordinate plane. Then we're going to visualize, or I prefer to actually make a right triangle. We're going to find X, Y, and R. R stands for the radius. Okay. And then use the chart to determine the ratios of the 6 trig functions. So this part right here that I have sketched in here is a description of everything that we're going to be using in order to do these problems. So you can see I was given the point X, Y. I graphed it. I know that that creates, if I look at a line from the center to that point, that creates my radius of this particular circle. Okay. So I have theta is my angle right in there. I know to get to the point XY, I had to travel X to the right and then up Y. All right. So in order to find the length of R, I'm going to use Pythagorean theorem. Once I have X, Y, and R, I can then substitute them in to find the 6 different trig functions. Okay. Hopefully that makes sense. We're going to do an example or two just to make sure that you guys can kind of see what's all going on. It's not really complicated. It just takes a little bit of effort and work. Okay. All right. So the first question here says find the exact value of the 6 trig functions given the point 8, -15. So the first thing I want to do is I want to sketch where is this point 8, -15. So 8, -15 is going to be somewhere down here. All right, 8, -15 there. Now I recognize that there is a triangle that gets created right here. I always like to use dashed lines. You could use solid lines if you wanted to. But there's a right triangle that's getting created right there. I know this right triangle has an x value of 8. It has a y value of -15. I know it should be positive because it's the length of a side, but remember, we're going off of its position. So if I have 15 squared, or -15 squared, plus 8 squared, that gives me 289, and the square root of 289 tells me that this should be 17, right? So just by looking at its position, I was able to figure these 3 things out. All right. Now I'm ready to go over here to what I refer to as my chart. Okay. If you notice, we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, but we change the opposite, the adjacent, and the hypotenuse to now letters of that triangle. Okay. Here's an easy way that I always remember it. Think about cosine and sine. Cosine and sine are in alphabetical order if I think of them in that order. Cosine C, sine S. I know that X comes before Y alphabetically. So cosine goes with X, sine goes with Y. That's how I keep that straight in my own brain skull. All right, so let's take a look here. The first thing I want to do, where is my theta? Well, actually, this right here is my theta. So I'm trying to find the sine, cosine, and tangent of an angle that is well beyond 90, well beyond 180, and even beyond 270 degrees, or it could have even been a negative angle. All right, if a negative angle would have been an angle right in there. So let's take a look here. If I want to find the sine of theta, I know that sine goes with y. I know my y value was negative 15, and I know that the hypotenuse there is 17. Pretty easy. That's it. All right. I know that the cosine of theta, cosine goes with x, so I know that this is going to be 8 over 17. Again, that's it. All right. Tangent of theta. The tangent of theta, all right, I always remember I remember it like this. I remember it's sine over cosine. Okay, or you could remember opposite over adjacent, right? So that think of that theta being right in at the vertex by the origin, all right? And this would be negative 15 over 8. All right. Now I need to find the three reciprocal trig functions. So this would be cosecant of theta. Take the fraction, flip it over. Negative 17/15. I always like to put the negative with the top. Secant of theta would be 17 over 8. And the cotangent of theta would be negative 8/15. Those are the 6 exact values. All right. So the second problem that we're going to do here is find the 6 trig functions for a 180-degree angle. Okay. Again, don't change your process. Sketch the angle first. So I know that a 180-degree angle is going to have an initial side out this way and a terminal side out that way. So let's take a look here. This is 180 degrees. I now need to reference what it means to be the unit circle. A unit circle, we said in the previous lesson, means that it has a radius of 1. What that tells me is that I have a point out here that has a radius of 1. All right, so this is going to be the point negative 1, 0. Now, if I think about this, all right, let's think about what my x, my y, and my z are here. All right, what are my x, my y, and my z? Sorry, not z. My x, y, and r. What are they at this position right here? All right, and this may be a little bit tricky, but the x value at that position, think about going from the origin of that point is negative 1. The y value is 0. What would the radius be? Well, we know that this radius is the same as the x, so the radius is going to be 1. Okay? So with that information, I can now find the sine of 180 degrees is 0 over 1, which would be 0. The cosine of 180 degrees, that's going to be x over r. So negative 1 over 1, or negative 1. And the tangent of 180 degrees would be opposite over adjacent, or 0 over negative 1, which would be 0. And if you don't believe me, test it on your calculator. If you take the sine of 180, the cosine of 180, or the tangent of 180, these are the answers that you're going to get. All right? But now we need to find the reciprocal functions. So let's do the CSC. The cosecant of 180 degrees. If I take the fraction 0 over 1 and flip it over, I get 1 over 0. 1 over 0 is undefined. All right? I can't divide anything by 0. How about the secant of 180 degrees? Well, the secant of 180 degrees would be 1 over negative 1, so we could just say that that's negative 1. All right? What about the cotangent? The cotangent of 180 degrees would be negative 1 over 0. Again, you can't divide by 0, so that is undefined. All right? So the second thing that we want to talk about is what's called reference angles. Sorry, I had to get a drink there. A reference angle is an angle that ends up being between 0 and 90 degrees. We will note that we are dealing with a reference angle by using something called theta prime. All right. So I broke this down just to make it as basic as I could for you guys. Okay. If an angle is in the first quadrant, if theta is in the first quadrant, then theta prime is equal to theta. If theta is in the second quadrant, then to find theta prime, the reference angle, we're going to take 180 minus theta. So again, if it's in quadrant 2, we're going to take 180 minus theta to get it somewhere between 0 and 90. Now, if it was in radians, we take pi minus theta to get theta prime. If it's in quadrant 3, theta prime would be theta minus 180 or theta minus pi. And then if it's in quadrant 4, theta prime would be 360 minus theta or 2 pi minus theta. All right, so a couple of quick examples here. The first thing I want you to do is make sure that you can sketch a 300-degree angle. So if I start right there, I know that 300 degrees is going to be a little bit beyond the 270. It has an initial side, the positive x-axis, and then it's going to come down right about here, creating this angle to be 300 degrees. Now, I notice that this terminal side is in quadrant 4. So its reference angle, or theta prime, is going to be found by taking 360 minus 300, or its reference angle is 60 degrees. That's it. Pretty simple. All right. How about negative 5 pi over 6? Well, let's sketch it first. I know that in radian measure, 180 degrees is the same as pi. This is a little bit less than pi, therefore it's a little bit less than 180 degrees. Okay? I know it has to have an initial side on the positive x-axis. I know because it's negative, I'm going to be moving clockwise, but I'm going to end up just short here of that 180 degrees, okay, or pi radians. All right. That tells me that my terminal side is in the third quadrant. All right. If the terminal side is in the third quadrant, again, there's your list. What I need to do to find theta prime is I need to take 180 minus 5 pi over 6. Wait a minute, that's not going to work, is it? That's not going to work because 180 is what? 180 is not radians. So I need to use theta, which is negative 5 pi. Let me look at this real quick. Okay, yeah, so quadrant 3, we're going to take theta minus pi. So I'm going to take negative 5 pi over 6 minus pi, which I'm going to say is 6 pi over 6. All right, that's going to give me negative 11 pi over 6. So let's think about this for a second. Negative 11 pi over 6 is in the first quadrant, but it's kind of weird. It doesn't feel like it's between 0 and 90 or between 0 and pi over 2. And in fact, it's not. So once I have this negative measure, and I notice this negative measure right here, I'm going to go ahead and say, well, theta prime is really the positive representation of that angle in this first quadrant, which would be pi over 6. All right. Now that I may need to explain to you guys a little bit more clearly, so let me know if you need me to do that. Okay. All right. So the last thing we got to do is called finding the exact value of a trig function. I broke down the steps as best I can here. The first thing you want to do is sketch an angle and make a right triangle, again to identify x, y, and r. Make sure, as we did earlier, make sure that you're paying attention to quadrant values. That means like in quadrant 1, x and y are both positive. In quadrant 2, x is negative, y is positive, and so on. We're going to need to be able to use the 30, 60, 90 rules, 45, 45, 90 rules, and maybe even the Pythagorean theorem in order to help us to find x, y, and r. All right. Once I have that information, then what I'm going to do is create a ratio from that information and then simplify the ratio if necessary. All right. So this is kind of the biggest challenge I think of this section. All right. So the first thing, let's see, they give us the sine of 135. They want us to sketch the angle. I'm big on this. You got to visualize what the angle is first. All right. So I'm going to go ahead and draw a quick sketch here of a 135-degree angle. I know that 135 degrees has an initial side there and a terminal side there. Okay? And I know that this is measuring that 135 degrees. But now I have to kind of change my thought pattern just a little bit. I know that there exists some point out there. Remember at the beginning of the lesson, they gave us that point. Right now, they're not giving us that point. Okay? So I need to figure out what is the y value where that point is and what is the x value where that point is. Well, I can do that if I know some more information. So here's the way that I look at this. I know that if I look at this left side of the coordinate plane, all right, and I move up, I know that 135 degrees is 45 degrees short of 180. Which tells me this measurement right here is 45. That's indicating to me that I have a 45, 45, 90 right triangle. The second bit of information is critical. Because I am dealing with this thing called the unit circle, I know that the distance from the origin to that point is going to be 1. A unit circle has a radius of 1. So now what I have to do is figure out what this x value is and what this y value is, and then I'll be able to find the sine of that angle, okay? The challenge of this is a lot of you guys just simply want to go sine 135 on your calculator. The problem is they want an exact value. The calculator is only going to give you an approximated value. All right, so in a 45, 45, 90, I know in order to go from the hypotenuse to a leg, I have to divide by the square root of 2. So that tells me each of these legs are 1 divided by the square root of 2. All right. So with just that information, I'm now ready to go ahead and find the sine of 135 degrees. I know that the sine refers to the y, 1 over the square root of 2. And I'm going to divide that by the r, which is 1. And because I had a fraction on top, I'm going to write 1 over 1. From here, I'm going to do big C, little c. So I get 1 over the square root of 2. And because the denominator is irrational, I'm going to rationalize this. So I know that the sine of 135 is going to be the square root of 2 over 2. Now, that's it. We're done. What you got to be careful of, guys, would be, for example, if I were to have asked you for the cosine of 135. Now, remember, I didn't ask you this, but here's what you got to be careful of. If I look at the cosine, even though we know this x value here is 1 over the square root of 2, it's really negative. Why? Because we're moving to the left on the x-axis. All right? So that's one thing you got to be careful of. So this would have been negative 1 over the square root of 2 divided by 1 over 1, which would be negative 1 over the square root of 2, or the cosine of 135 would have been negative radical 2 over 2. All right? So be cautious with that. Now, what if I threw one at you that I asked you to find the cotangent of 7 pi over 3. Holy crapicola. Well, the first thing is I'm going to sketch it. I got to see what the heck this thing even looks like. I noticed that 7/3, or 7 pi over 3, is more than one time around the circle. All right? I know that one time around the coordinate plane is 360 degrees, or 2 pi radians. So 7 pi over 3 actually is going to have an initial side here and a terminal side coming up like this. All right? And then again, just so you see that angle, this would be that angle, 7 pi over 3. Now, I need to reference this into the first quadrant. And I noticed that this angle right here is a little bit beyond the initial side. So what I'm going to do is I'm going to say, all right, how far beyond? It's 7 pi over 3 minus 6 pi over 3. I took that extra turn around the circle off. And that tells me that this is a theta of pi over 3. Now, personally, I don't like to deal with pi over 3 or radians, so I'm going to go ahead and change this into degrees by multiplying by 180 over pi, and that tells me, hey, you're really dealing right here with a 60-degree angle. That makes a whole lot more sense to me. All right, so in this triangle now, I'm going to put a point right here, and I use solid there. I could have used dashed. All right, there's my right triangle, and I know this right triangle has a radius of 1. So if 1 is the length of the hypotenuse, even though my picture doesn't look like this, shorty would be across from the 30. I know to go from the hypotenuse to shorty, I divide by 2. I know to go from shorty to the long side, I'm going to multiply by the square root of 3, which will give me radical 3 over 2. All right? So now I need to find the cotangent of this angle. Well, I know that tangent is opposite over adjacent. So the cotangent would be adjacent over opposite. The cotangent of 7 pi over 3 is going to be the adjacent side, 1/2, divided by the opposite side from 60, radical 3 over 2, which would give me big C, little c here. I would get 2 over 2 radical 3, which would be 1 over the square root of 3, and then rationalize it, radical 3 over 3. Again, I didn't have to worry about signs, again, because it ended up being in the first one. All right, so we got a lot of time to practice between Wednesday and Thursday on this stuff, so let me know if you have any questions.